And welcome to a ramble with me. We are looking at question 10 of IEB November 2022, paper 2. Losing track of the twos. Right, in the diagram below, ABCD represents a closed door 1,2 meters wide and 2,2 meters in length. When the door is open 42 degrees along its hinge AD, its new position is represented by AEFD. Determine the size of FAC. Okay, so that angle there. So the angle between the diagonal of the closed door and that same diagonal when that door is open by 42 degrees. Okay, and the key thing being that this rectangle has the same dimensions as this one, so AE is also 1,2 meters, EF is 2,2, and so on. Okay, so we are trying to figure out FAC. So I mean, the first key thing is kind of in what I said. AF is the diagonal of this rectangle. AC is the diagonal of the closed door. Those are going to be the same length. And then down here in this triangle, we have an angle, we have this length, we have this length. Those are both 1,2, which we can use to work out the length of FC. So now we've got the three lengths, and we can use that to work out the angle FAC using the cosine rule. And that seems like the best way to go, because if we wanted to use the sine rule, for instance, then we would have needed some other angle inside FAC. And I don't, I guess, no, yeah, how would we get that? I don't see how we would get that. So, yeah, that's the plan of action. Let's do it. Making on. Okay, right. So we are seeing that, first of all, BC is equal to 2,2 because opposite sides of a rectangle are equal. So this is 2,2, and then we can use that to work out AC. So I mean, yeah, they haven't told us explicitly this is a rectangle, but hey man, it is. So we're using that to make a whole bunch of interesting assumptions here. B is a 90 degree because interior angles of rectangle. Whoa, what just happened? Okay, are all 90 degrees. So now we can do some Pythagorean. So AC squared is equal to AB squared plus BC squared, and that's because Pythag said so. So that is going to be 1,2 squared plus 2,2 squared. That for me is going straight into the calculus. So that is 6,28. Okay, and so therefore AC, I'm just going to leave it as that. Right. And we know that AEFG and ABCD are congruent, and that's because it's literally the same door. Right? So therefore we know that AF will have the same length as AC, will also be the square root of 6,28. Okay, so far we have this length, we have that length, and now we want to find this length over here. Okay, so we know that DC is equal to DF because again of the congruency of these two rectangles. So that means that DC, well, and also, oops, maybe before mentioning that, we know that DC is equal to AB, so it will also be 1, 2. Right, because opposite sides of rectangle are equal. Okay, so therefore DF is also equal to 1, 2. So now we have 1, 2, 1, 2, and this angle we've been given 42 degrees. So I'm just going to draw that out quick. So actually, let me draw it kind of the way that it's, so it's like this, where this is 42 and DCF, and we have noted that both of these are 1, 2. Okay, let's take you where you belong, my friend. Okay, so we're going to use the cosine rule to figure out this length over here. So I'm going to start by labeling little d, little c, little f. So the cosine rule tells us that d squared is equal to c squared plus f squared minus 2cf cos of d. So cf squared is equal to 1, 2 squared plus 1, 2 squared minus 2 times 1, 2, 1, 2, cos 42. And that should go to a calculator. So that is 0,739 blah blah blah. So therefore CF will be the square root of that, which is okay, right. So we now have the length of this, which is 0,860 blah blah blah, and over here we have the square root of 6,28 and ditto over here. Right, so let's just draw that triangle for ourselves a bit more clearly here. So it is ACF. We have the square root of 6,28 here, the square root of 6,28 here, and then 0,860 blah 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 over here. And we are trying to find the angle FAC. So that again smells like a cosine rule thing. Right. Okay, so the cosine rule tells us, so I want this angle, so I'm going to write a squared is equal to c squared plus f squared minus 2cf cos of a, and then rearrange this so that I get the angle by itself, or I try to. Okay, divide both sides. by the minus 2 CF. Okay, then we can just leave it like that for now. I'm just gonna divide by the negative 1, switch my signs up. So I'm going to end up with positive c squared, positive f squared, negative a squared over 2cf is equal to cos a. Okay, now we can sub in our values. So c and f are root 6,28. So if I square that, I'm just going to get 6,28. And same for this guy. And then the a squared, so that's this guy squared, which is this 0,739 what. Okay, and then down here we have 2 times the square root of 6,28, and this is also the square root of 6,28 is equal to cos of a. Okay, so let's see what that comes to. Let me just square this to get my 0,39. Okay, times it by negative 1 so that it can be a minus. Okay, then add my 6.28, 2 of them, divide that by 2 times, okay, so this is going to be root 6.28 times root 6.28, that's just going to be 6.28. Okay, so then we get cos of a is equal to positive 0,941 blah blah blah. Okay, and because we're working in the context of a triangle, we know that a is some number between 0 and 180, so first or second quadrant angles, and because the cosine ratio of a is positive, that means it must be in the first quadrant. So a is equal to inverse of cos of this number, which is 19,8 degrees. Okay, so that is that angle now, which is the angle we were looking for. Okay, let's see what the memo thinks. I don't even think I have the memo open. The chaos of it all. Getting there. Question 10. Yes, 19,8. We are in agreement. Cool. Let's see if there's interesting alternatives here. Yeah, these things are so hard to read. There's just so much going on there. Okay, so the only real difference in approaches is in how they find the length of this side. So we used the cosine rule in this triangle, but an alternative is to recognize that this is actually an isosceles triangle. So you could use that to figure out the size of each of these angles, and then you could use the sine rule to figure out the length of CF, because you have these lengths, you have these angles. So you could use the sine rule, but otherwise the approach is the same in terms of using the diagonal of the rectangle and blah 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 blah. Okay, cool. Great chat. Catch you another time.